In this lesson, we're going to talk about functions. A function is a special relation in which each member of the domain is paired with exactly one member of the range. So when we talk about the word relation, a relation is a set of ordered pairs, such as an ordered pair of 1, 2, 2, 4, 3, 0, and 4, 5. All these ordered pairs, or the set of these ordered pairs, is the relation. Function is a special relation in which each member of the domain is paired with exactly one member of the range. So let's talk about the domain and the range. The domain is the set of all the x values. The range is the set of all the y values. So again, the domain is all the x values, and the range is a set of all the y values. Here's a graph with a couple of coordinates graphed. 1, 2, 2, 4, 4, 5, and 3, 0. Looking at these coordinates, the domain, again, is the x values. So on this first coordinate, 1, 2, the domain here is 1. Coordinates 2, 4, the domain is 2, 4, and 3. The domains are all in green. So when asked the domain is 1, 2, 3, and 4. The range, on the other hand, is the set of all the y values. Usually when you list your domain and range, it should go from least to greatest. So our least range here is 0, followed by 2, 4, and 5. So the domain, 1, 2, 3, 4, 5, all my x values. The range, 0, 2, 4, and 5, all the y values. Try listing these domain and ranges on your own. Negative 4, 1, negative 2, 3, 0, 1, 3, negative 1. When looking for the domain, again, this is all the x values. Let's go left to right. Anything from the left side will be smaller and the x values will increase as you keep going to the right. So you're going from negative infinity to positive infinity. The further you move right along the x-axis, the larger your x value becomes. So what is the first x value you see here going from left to right? You should see a negative 4, followed by a negative 2, followed by 0, and ending with 3. When you're listing your range, your smallest values are the ones that are lowest on the graph. So in this case, you want to go from bottom to top. So how low, what's the lowest y value you see here? The lowest y value here is negative 1. The next one is 1 and 1 again. Now with this duplicate, you don't have to write it once. I'm sorry, you don't have to write it twice. You can just write it one time. So negative 1, 1, and then the highest y value here is 3. So my domain is negative 4, negative 2, 0, 3, and my range is negative 1, 1, 3. Here's a set of relations. Is this set a function? Do these ordered pairs create a function? So remember, going back to the definition, a function is a special relation in which each member of the domain is paired with exactly one member of the range. One of the easiest ways to identify whether this is a function, if we just highlight the x values here, if you take a look at all the x values, one of the simplest questions you can ask yourself, do any of my x values repeat? In this case, none of my x values repeat, so we can say yes, this is a function. As long as the x values do not repeat, then you have created a function. Let's take a look at another example. Is this a function? Again, I would maybe highlight all the x values. And let's take a look at these x values that I highlighted. Do any of my x values here repeat? Well, yes. Our negative 10 repeats. So we have two x values that are negative 10. When two of the x values repeat, then this is not a function. So again, if the x values repeat, not a function. If the x values do not repeat, then it is a function. Let's take a look at a table. Is this a function? Go straight down your x values. This one's nice and easy for you. The domain, again, are the set of the x values. The range is the set of the y values. Do any of my x values repeat? -3, -1, 0, 1, 2. None of my x values repeat, very easily seen. So is this a function? We can answer, yes, this is a function. Looking at my next example, again, highlighting the x values here. 5, 2, -7, 2, 5. Well, in this case, yeah, we have the 5s that repeat, and we also have the 2s that repeat. So we have two x values, both repeating. So is this a function? If you said no, that is correct. No, this is not a function. So we looked at the relations, we looked at the graph, and our next example is a mapping. Now this one can seem a little bit more confusing. 3, 6, so my x values are 3, 6, -4, 2. The y value is -5, 7, 10, -1, and -7. Now it's hard to tell exactly. We're not going to just look at these values here and say, do any of these values repeat? What we want to see is, do any of them repeat as far as setting up a ordered pair? One strategy at first, until you get used to this setting, to this view, is maybe writing each one down. So if we look at 3, 3 pairs up with 10, so that creates the ordered pair 3, 10. 6 pairs up with -5, creating the ordered pair 6, -5. -4 pairs up with 7, creating the ordered pair -4, 7. And -4 also pairs up with -1, creating the ordered pair -4, 1. And 2 pairs up with -7. Now again, if we highlight all the x values, or all our domains, the question we're going to ask ourselves is, do any of my x values repeat? Now if you notice, the -4s repeat. So the -4 is being paired up with two different y values. According to our definition, each member of the domain is paired with exactly one member of the range. So if we ask ourselves, is this a function? The answer should be no. This is not a function. One of the x values repeats, going to two different members of the range. Our next example, we have our ordered pair is being paired up, and we have something called a vertical line test. Vertical line test. Here's our graph. Here's a couple coordinates paired coordinate. We're going to run this vertical line across the whole graph. Once we run this against the whole graph, if this line, this vertical line, touches any 2 points, so if we notice here, this vertical line here only touches 1 point, 1 point, 1 point, but if we drag it back, at this location here, this vertical line is touching two different coordinates. The vertical line test states if this vertical line touches two different coordinates, then this again is not a function. The vertical line test states in order for this to be a function, it may not cross two different coordinates. It may only cross one coordinate at a time. So this vertical line test here crosses two different coordinates, -4, 7, and -4, 1. And again, if we take a look at the x values, -4 and -4, we have two coordinates with the same x value. This is not a function. Let's take a look at another example. So here are 4 examples. Function or not? Test your knowledge here. Take a second, hit the pause, try to figure this one out. Once you've come back, again, let's look at our strategies. Is this a function? Highlighting my domains, -1, 4, 2, and 1. Do any of my x values repeat? None of them repeat. So is this a function? Yes. Each member of my domain is paired with exactly one member of my range. Let's look at our next example. -2, 4, 24, and 5. Do any of these domains repeat? In this case, no. Answer is no, none of them repeat. So is this a function? Yes. This is a function as well. Example number 3, highlighting the -5, -2, 5, and 2. Do any of my x values here repeat? Yes, we see that the 5s are both paired up with two different y values, two members of our range. So no, this is not a function. And our last one here, number 4, I'm going to bring this one up just like 3 pairs of 4, 2 pairs of 4, 1 pairs of 3, 5 pairs of 3. Again, if this is a little bit hard to see here, let's write the ordered pairs. So we have the ordered pair 3, 4. We have the ordered pair 2, 4. We also have the ordered pair 1, 3. And last but not least, we have the ordered pair 5, 3. Now notice the y values in some of these repeat, but that is okay. The y values are allowed to repeat. What we're concentrating on is just the x values. Do any of my x values repeat here? Well, 3, 2, 1, and 5, none of my x values repeat, so is this a function? Yes, this is also a function. Let's take a look at a graph and see if our graph is a function. So our graph starts here at -5, runs up, comes down, comes back up, and stops here at the range of 5 as well, at the x value of 5 as well. So for easiest way for us to figure out whether this is a function, let's draw ourselves a nice vertical line here, and let's run this vertical line across my graph and ask ourselves, is there any point on this graph that this vertical line touches two different coordinates? If you notice, it only touches the graph at one particular point all the way through the graph. So in this case, is this a function? Well, if it doesn't touch any 2 points, then yes, this is a function. Let's extend the lesson a little bit. Asking for the domain and range here. The domain is a set of all x values, and the range again is a set of all y values. So what x values are here? Well, if you look from left to right, our x values start at -5 and all the way on, all the way through 5. Now there's an unlimited amount of x values in between -5 and 5, because we could say this is -5, -4.99, -4.9999, and so on. So there's an infinite amount of points between 0 and 1. So when we want to write a range or domain or range for this one, we're going to use bracket notation, start from the least or the smallest x value, which is -5, and all the way to our greatest x value, which in this case here is 5. And we're going to do the same for the, that should be a bracket. And we're going to do the same here for our range. Our lowest y value here is nothing lower than a -1. And our highest y value here is at +4. So our domain is every number between -1 and 4. Our domain is every x value between -5 and 5.